Hello, so a bit of help with week 5, lesson 3, question 4, part 3. Basically, we've got 3 points, R, S and T, tells you where they are. And it tells you that the first job is to show they are collinear. So they must be on a line with R and T, and S is going to be somewhere in the middle, but we just don't know where. S stands for somewhere, I guess. Is it kind of over this end? Because our second job is to find the ratio in which S divides R to T. Basically, what proportion of the way along this line does S sit? So, first of all, to show they're collinear, well, a good idea to me seems to be to work out how do you get from here to here, how do you get from here to here. So, let's start by working out how do I get from R to S. Well, R is at 6, 7. S is at 10, 13. How do I get between them? What is the vector from R to S? Well, from 6 up to 10 is up 4. From 7 up to 13 is up 6. So this is my vector from R to S. This is how I get from here to here. Similarly, let's work out how to get from S from T. So S to T, that means going from 10, 13 all the way up to 16, 22. So the vector from S to T, how do I do it? I go up 6, I go up 9. And there we go. Now you can probably already jumps out at you what the ratio of the two lengths is. So to prove they're collinear first, we have to write a wee sentence. And how we're going to do it, what I'm going to do is say that ST is going to be 3 over 2 lots of 4, 6, I think that works. So 3 times 4 is 12, divided by 2 is 6. 6 times 3 is 18, divided by 2 is 9. So basically, this numbers here, they come out when I do 3 over 2 times that whole vector. And what that means is it's 3 over 2 times by the vector RS. And what that means is that they point in the same direction. This one just goes a bit further. As you can see, they point in the same direction. This one just goes a bit further. And the reason is because to get from these numbers to these numbers, you times them both by 3 and then half them both. So now I've shown that ST is just some number times by RS. Then I can write down a sentence, something along the lines of ST and RS are parallel because ST equals 3 over 2 RS. And then I can say both ST and RS pass through the point S. Hence, we have ST and RS are collinear. They're parallel, they go in the same direction, they go through the same point S, so they are on the same straight line. So co, meaning like sharing, like co-pilot, linear meaning line, so collinear, sharing the same line, they're on the same line because we've shown they're parallel and we've shown that they share a point. So there you go. It says now, find the ratio in which S divides RT. Well, I've pretty much got there, actually. So if we want a ratio, we want to know what is the ratio RS to ST. Well, one way you can do this is you can look at RS. So just look at the x-coordinate is enough. It's got 4. ST, the x-coordinate is 6. So the ratio 4 to 6, you can simplify that as the ratio 2 to 3. So that's the ratio in which S divides RT is the ratio of RS to ST. The ratio of that bit to that bit. Sorry, the ratio of that bit to that bit. If you wanted to, just for fun, you can check it. The ratio of RS to ST using the y coordinates essentially. So 6 for RS, 9 for ST, simplify that down, divide them both by 3, and you get 2 to 3, the same ratio. Incidentally, the only reason it's the same ratio is because they are parallel. So that's where this links in. And you can see what I did when I found out they were parallel is you times by 3 and divide by 2. That's exactly what this ratio here says. To turn from here to here, you divide by 2 times by 3. So there you go.